All right, CNT120, we're working on Chapter 3. We're working on IP addresses. We're continuing on with IP version 4. So we just got done looking at static IP addresses, dynamic IP addresses, and kind of dissecting all the pieces. And we even looked at ipconfig for Windows computers, ifconfig for Linux and Apple computers, okay? Real quickly before we go any further, they mention in the book something called a subnet. Let me give you just a quick taste of this. Subnets are very common with IP version 4 addresses. They're a smaller piece of a larger network, and they're created on purpose by somebody like a network admin, and they're used for organizing the network, setting up little barriers for security, a little bit of traffic control in networks, and they're very purposely built and done in a network for those reasons by a network admin. Example, I would have a network like so. I might have a network like 172.16.0.0 with a normal subnet mask of blah. And what I might do is I might purposely change my subnet mask to this, which allows, instead of having, two network portions and two host portions, I now have two network portions, a little teeny subnet portion, and then a host portion. And what that allows me to do is take my whole big pile of network and break it into some smaller pieces now. That's going to allow me to create a little subnet for the desktop computers, a little subnet for IP phones, a little subnet for wireless users, and so forth. That allows me to have all these devices connected together on the same physical network, but logically, through the router, I'm dividing them into separate little groups that they don't actually communicate with each other. So the desktop computers don't actually directly communicate with the IP phones. Wireless users don't actually directly communicate with the desktop computers or IP phones. So I'm kind of separating them out by security, and that is done with some configuration on these devices here. And it's really not that hard. It's something we do with our second level networking students. We actually start configuring this and configuring subnets on purpose. For you, for now, just realize it can be a very purposeful done thing for these reasons by a network admin. And it can be as simple as doing this, taking this whole big network and breaking it into some pieces by altering our subnet mask. Then I do need to know, I need to understand the numbers I'm using, but I can create a little subnet for these users, subnet for these users, subnet for these users. That way I'm separating them for security reasons. That's why I might do that. So when they mention something in there, just realize that much for now. We'll add to that or build on that later. All right, they remind us two types of IP addresses, IP4, IP6. We're going to now spend some time on IP4, digging into that a little bit deeper. Okay, IP version 4 address, 32-bit address, organized into 4 groups of decimal numbers. Those decimal numbers are actually 8 bits long. Known as an octet. That's where that octet name comes from. There's 8 bits, so octet, octopus, 8 legs, 8 arms, whatever you want to say. Octet is 8 bits, and each of those octets can range from 0 to 255. And there are a couple IP addresses that are set aside and not reserved. We typically represent it with a dotted decimal notation. Example, 192.168.10.48. Those are all decimal numbers with a dot between them. And again, each one of those numbers goes from 0 to 255, or all zeros in binary up to all ones in binary. Typically, we see this right here, 192.168.10.48. Everything else, the computer, the routers, the switches, all that stuff, see this number here. It's all in binary. That's what the network and devices on your network see. We see the decimal, they see the binary. Hence why we worry about binary conversions. If I do an ifconfig on a Windows or a Linux or Apple computer, I can find my IP address like so. If I do my ipconfig on a Windows machine, I can see my IP address like so. Okay, just a reminder, we've done it before, but we'll do it again. If I'm on my Windows computer at the command prompt, ipconfig, that'll show me my IP address, right, like that, right there. On my Linux machine, I can do ifconfig, that'll show me my IP address right there. Okay, there's my IP version 4 address. There are different classes of IP version 4 addresses, and this is really from the days of when IP addressing was set up back in the 70s and 80s. IANA created classes of addresses, and the classes of addresses were allocated and handed out for different types of organizations that would be connecting to the internet. So they created ABC addresses. They also created D&E that were for special purposes. A, B, and C addresses we're going to look at in just a minute. And then D&E were set aside for some special purpose we'll show you in a little bit as well. D for multicasting. E was set aside for research. All right, so let's start going through these. Class A networks were set up that the first octet was the number that the IANA or ICANN allocated, and the remaining 3 octets were for you to use as you needed, as the network administrator could use as they needed. So the first octet was kind of, for lack of a better term, carved into stone, and the remaining 3 octets were for you to use how you wanted to use them. So this allowed mathematically these remaining 24 bits, 8 plus 8 plus 8, those remaining 24 bits could be set aside for hosts, which gives you mathematically 16,778,214 addresses for nodes on your network. So this was set aside typically for government use, as in governments of the world use. Sometimes we forget we're sitting in our country and we forget there's other countries out there. So this was set aside for governments of the world. An example would be a 50,000. That 50 number right there, that first octet, tells you it's a Class A, because if I look at the first octet of a Class A address, that beginning number is going to be from 1 to 126. So if I see a 70 dot blah, a 50 dot blah, a 20 dot blah, I know it's a Class A network. Okay. Class B, IANA, ICANN dictated or specified the first 2 octets that were to be used, and the remaining 2 octets were for you or the network administrator to allocate how you saw fit, however you needed. So mathematically, that gave us 16 bits here, 8 plus 8, 16 bits for host, so 2 to the 16 gives you 65,534 addresses on your Class B network. So this was set aside for large businesses, global businesses, if you will. So an example that would be 185.96.0.0. The 185, that first octet, was a clue that it's a Class B network. Again, Class B, first octet 128 to 191. Now, we didn't skip 127. We're going to come to that in a minute. So if you start looking through and see 1 to 126, no, 127, 128, okay, we're going to get to that in a minute. So hold on to that one. Class B, 128 to 191. So if I see a 150 dot blah dot blah, I know it's a Class B. If I see a 180 dot blah dot blah, I know it's a Class B. Class C, IANA, ICANN dictated the first 3 octets. The remaining octet was for us to use how we saw fit. So mathematically, there's 8 bits there to work with, so 2 to the 8, 254 host address for my Class C network, which again, back in the 1970s, early 80s, was a lot of nodes. This was a lot of nodes. Think about it, in your house, you have a handful now, but back in those days, you're lucky if you had a computer in your house. A handful of computers in a whole company. So plenty of space in those days. So Class C's were set aside for everybody else. And that included, mom and pop businesses, even schools and universities in those days. Entire university would get a Class C. So an example would be 210.32.67. 210, that first octet is telling you is a Class C. Here's your Class C. First octet goes 192 to 223. So 195 dot blah dot blah, 210 dot blah dot blah. That is a Class C address. Class C address. Class D was set aside for multicasting. First octet 224 to 239. This was set aside for multicasting. Well, super quickly, unicast is data sent to a single node. Unicast. Unicycle has 1 wheel. Bicycle has 2 wheels. Unicycle is 1 wheel. So a unicast is a message going to one node, a single node. A broadcast is a message going to all nodes. We're talking about everybody in the network. Or as I like to joke, that's something you would yell out in a room, hey, free donuts next door. That's something I want everybody to hear, so it'd be a broadcast message. Hey, free donuts next door. Hey, free coffee next door. Okay? That's a message going to everybody, all nodes on the network. Well, there are times I want just a few nodes to get a piece of information, and that would be a multicast. That gets used for things like multimedia streams or multimedia conferences. I might have 2 or 3 computers in a whole office that need this multimedia stream. So multicasting gets used to get that data to 2 or 3 nodes. Not one, not all, but 2 or 3. This also gets used by some routing protocols, so you can send a message to just all the routers. Not the switches, not the servers, just the routers, if you will. So multicasting gets used for that purpose. A few nodes. Well, Class D was set aside to do that. Class D was set aside to do that. Class C was set aside right off the bat for experimental or research, if you will. Experimental or research. So, the book shows you a diagram like so, showing you the first 8 bits for Class A, the remaining are host. Class B, the first 16 bits. The remaining are hosts. Class C, the first 24 bits, the remaining are hosts. That's what they're trying to show you with that. This diagram as well is trying to show you that too. Here, trying to show you Class A, B, and C as well in a different format. So they're using a bunch of different charts and examples to show you the same thing I showed you. So whatever one clicks for you. Now, when we talk IP addressing, we also need to talk Subnet Mask. I talked about this a little bit before, but I'll talk a little bit more detailed now. I like to think of the Subnet Mask almost as an IP address decoder. It's a 32-bit number that identifies the network, subnet, and host portions of an address. Well, the network or subnet portion, if there is one, is all ones. The host portion would be all zeros. So therefore, if I have a Class A network, which we knew was network, host, 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 the network portion is getting represented by all ones or 255, 255.0.0.0. Class B, we said, was network, network, host, host. The first 2 octets network, so I'm representing with all ones or 255, 255. And Class C, the first 3 octets are network, the remaining is host, so 255, 255, 255, 0. And that's showing me, that Subnet Mask is showing me what portions are network, what portions are host. That's what that's actually trying to show me. So, in a normal Class A network, I might have 110.50.32.72. We know it's network, host, 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 and we know the Subnet Mask is 255.0.0.0. That's all normal. If there's subnetting going on, I might see this. And you notice I highlighted it in red, 255.224.0.0. That starts to stand out now. I know something has occurred there because that looks different. That's why this default subnet mask is important. This is the normal structure. This is the normal subnet mask. This is out of the ordinary. I know something has occurred. In this case, subnetting. Class B, 150.39. We know it's network, network, host, host. The first 2 octets are specified. The remaining are host. So it should be 255, 255.0.0. That's what it should be. That's all normal. Here I have an instance where I have 255, 255, 240. Again, red flag. I know subnetting has occurred there. You know, later on I'll learn how to decipher and what is actually happening, but I at least know subnetting has occurred. Something's happening there. Class C, normal is, there's 210.83, okay. Normal network, network, network host. Normal 255, 255, 255.0. If I come down here and see a 255, 255, 255, 248, I know subnetting has occurred. Subnetting has occurred. Okay. So the idea behind these defaults is to recognize normal so that I can pick out what is different and at least know I'm dealing with something different. And that's what the subnet mask is there for, to tell you what has changed, what is different. And again, if I'll look at our college computer here real quick and look at I'll do another IP config. If I do another IP config and see the college computer, they're running a 172, and with a Class B, I expect it to be 255, 255.0.0, but I actually see 2520. I know some kind of subnetting has occurred here. And again, eventually we'll learn what that is, but I at least know what it should be, and I know it's different. And that's the idea behind the subnet mask. I know something has occurred. I would need to get maybe some pencil or paper out and figure it out, but that's the gist behind that. That subnet mask is there to tell you what is network, what is host, and if any subnetting has occurred. I'm going to come back in the next podcast and talk about a few more special IPv4 addresses.